let me show you how to make a truth table, like this one from Quiz Prep 2.1 in the back of Chapter 2. The truth tables tell us what the logic operations are, like tables 2.1 and table 2, and they can also demonstrate things like logical equivalence, which is what I'm going to do here, showing the rule that's known as hypothetical syllogism. I'll say what that is a little bit later. But for right now, we're going to have three variables. And for each one of these, we're going to look at filling in all combinations of trues and falses. So that's 2 choices per variable 3 times. That's 2 to the third, so I'm going to have 8 rows. And so to fill in the truth table, the first thing I do is fill in 8 rows, alternating trues and falses for the first variable. For the second variable, true, true, false, false. And for the third variable, 4 trues. Let's do the first subpiece. P implies Q. The only way it can be false is if P is true and Q is false. So it will be false here and here, and true everywhere else. Only way this can be true is if Q is true and R is false. It will be false here, and true everywhere else. Only way this can be true is if P is true and R is false, and true everywhere else. For this, I'm going to break it down. Always break things down. It makes it easier. A and B, well, that's going to be true only if both A and B are true. So here and here, and here, and here. Everywhere else, it will be false. The answer that I really want is this implies C, and this will be false only where the AND is true and C is false. So let's look for where C is false. Here, and the AND is true and C is true. So this is true everywhere. On the other hand, if we do this with if and only if C, then this is true if and only if they match. So true and true, match. False and false, match. True and false, do not match. False and false, match. Match, don't match, match, match. And there's our truth table. This is a tautology, which means no matter what P, Q, and R are, if we know that P implies Q and Q implies R, we get to conclude that P implies R. However, they're not equivalent. There are situations in which P implies Q and Q implies R is false, but P implies R can be true, and we can tell exactly what those situations are from this truth table. These are the situations where P and Q and R are true and Q is false, and where P and R are false but Q is true.